How does stress corrosion cracking endanger pipelines? Imagine a pipeline running miles underground, quietly carrying oil or gas. You might think it's safe because it looks fine from the outside. But hidden inside, a dangerous process could be weakening it without any obvious signs. That process is called stress corrosion cracking. It's a failure mode that combines two forces: mechanical stress and a corrosive environment. When these two come together, tiny cracks start to form and grow over time. These cracks are often microscopic and hard to see, but they can cause big problems. Stress corrosion cracking begins when small cracks develop on the pipeline surface. These cracks often form where residual stresses from welding or manufacturing are still present. They can also develop from the internal pressure of the fluid inside or external forces like soil shifting or ground movement. The environment around the pipeline, especially soil or water with specific chemicals, plays a big role. Certain chemicals, like chlorides or sulfates, can make the metal more vulnerable. Even low concentrations of these chemicals can trigger cracking if the conditions are right. The cracks usually grow in a specific pattern, often appearing as colonies of long, narrow cracks running along the pipe's length. Unlike general corrosion that thins the metal evenly, stress corrosion cracking causes localized damage. This means the pipe can look perfectly fine on the outside, but inside, it's riddled with tiny cracks that are slowly expanding. As these cracks grow, they weaken the pipe's ability to handle pressure. Eventually, the cracks can join together or become large enough to cause a rupture. This can lead to leaks or even catastrophic failure, which can be dangerous and costly. There are two main types of stress corrosion cracking in pipelines. One is high pH cracking, which occurs in more alkaline environments. The other is near-neutral pH cracking, which happens in environments with a pH close to neutral. Both types involve similar damage mechanisms, where the chemical environment and mechanical stress work together to cause cracks. The process can be quick once cracks reach a critical size, especially if the pipeline is under constant stress. Detecting stress corrosion cracking is tricky because the cracks are very fine and often hidden beneath coatings or soil. Regular inspections using techniques like ultrasonic testing or magnetic particle inspection are necessary to find early signs. Preventing this failure mode involves controlling the environment around the pipeline, reducing residual stresses through proper design and stress relief treatments, and choosing materials that resist cracking better. Monitoring is also key. Using sensors and inspection tools to catch small cracks early can save a lot of trouble later. If left unchecked, stress corrosion cracking can cause sudden pipeline failures that threaten safety, cause environmental damage, and lead to costly repairs. Understanding how this process works helps us appreciate why regular maintenance and careful material selection are so important in pipeline safety.